The first atmosphere of Earth, during the Hadean Eon, was composed of gases from the solar nebula, primarily hydrogen, and simple hydrides like water vapor, methane, and ammonia. This era saw intense heating from the moon-forming collision with Theia and impacts from large meteorites, which drove off the most volatile gases. The collision with Theia melted and ejected large portions of Earth's mantle and crust, releasing significant amounts of steam. This steam eventually cooled and condensed, contributing to the formation of ocean water by the end of the Hadean. As Earth's crust solidified at the end of the Hadean, the atmosphere cooled, causing most water vapor to condense into a superocean. Volcanic outgassing and gases from asteroid impacts during the late heavy bombardment created the Archean atmosphere, rich in nitrogen, carbon dioxide, methane, and inert gases. Much of the carbon dioxide dissolved in water and reacted with metals like calcium and magnesium, forming carbonates that settled as sediments. Evidence of water-related sediments dates back to 3.8 billion years ago, indicating the presence of liquid water early in Earth's history. The constant rearrangement of continents by plate tectonics has influenced the long-term evolution of the atmosphere by transferring carbon dioxide to and from large continental carbonate stores. Free oxygen did not appear in the atmosphere until about 2.4 billion years ago during the Great Oxygenation Event. This event marked the end of banded iron formations, signaling the depletion of substrates that reacted with oxygen to produce ferric deposits. Before this, oxygen produced by cyanobacterial photosynthesis was removed by oxidation of reducing substances like ferrous iron, sulfur, and atmospheric methane. Oxygen began to accumulate only when its production rate exceeded the availability of reductant materials. This shift marked the transition from a reducing to an oxidizing atmosphere, with oxygen levels eventually stabilizing above 15% by the end of the Precambrian.